Hello y'all, welcome to Universe Sandbox 2 episode 10. Today we're going to be terraforming, well, all of Jupiter's major moons, Io, Europa, Ganymede, and Callisto. Thank Yoodle Studios for the suggestion. So, as I told you before, I had to downgrade to 23.2, so here we are. The good old 23.2 interface. So yeah, let's let this run for a bit just to make sure everything's working fine, because yeah, I had to delete all the other plans to make sure there weren't any performance issues, although there usually isn't. Well, I picked the preset that had all major moons and all planets, so, that's just kinda chaotic. When I say kinda, you get what I mean. Also, one more thing I need to switch off. John's Escape, which I told you before, simulates the fact that these moons are too small to hold on for an atmosphere for more than, say, 1,000,000 years, except it simulates at a ridiculously fast pace. So yeah, John's Escape is off. In fact, I'll just turn off volatiles along with that. So yeah, now we got these moons. Of course, they're well beyond the habitable zone. But that doesn't mean there aren't ways to terraform it. I'm just going to show you the habitable zone first. The blue is like the very, very edge. Anywhere beyond that, you're just done. And yeah, there's Jupiter. Now you all may be wondering, how? Well, it's simple. Actually, not that simple, but yeah, you have to use sulfur hexafluoride. That's a gas that's 30,000 times more effective than carbon dioxide. Yes, 30,000. You heard that right. 30,000. Sadly, it's actually a little bit more than 30,000, but yeah. Sadly, this thing does not simulate sulfur hexafluoride, not even carbon dioxide, especially at version 23.2. Even at the most recent versions, when they claim, quote-unquote, to simulate carbon dioxide, for some reason the simulation of carbon dioxide does not work. I really wish they could include sulfur hexafluoride, because that would really help these simulations. Sadly, sulfur hexafluoride is pretty rare, not because sulfur is rare, but more like fluorine is rare. But I'm sure we'd be able to get enough to terraform these planets. Now, some consider Io to be unterraformable simply because, all these volcanoes will spew out stuff that will break through the greenhouse layer and suddenly cause, chaos and, yeah. If you want to read more on this, you can just go check out the Terraforming wiki. It even has simulations on these. But yeah. Now, of course, these orbits are correct because they've automatically been done by this game. But yeah. So why don't we start? Step 1. Add an atmosphere. Now I'm just going to add 1 atmosphere of pressure and see how far it gets. Only 104, really? I kind of see where this is going, but yeah, even the scale height's a little bit of a mess here. But the scale height you don't need to worry about because it really doesn't do much here. So yeah, greenhouse effect. So our effective temperature is negative 148. So we need to be 163 degrees Celsius to greenhouse effect because 163 minus 148 is 15 degrees Celsius, which is Earth-like. So let's increase this. Come on, get down to 163 now. Come on, This is what I hate sometimes. When you're suddenly just all around, just so close to the value you want, except the value keeps on jumping all around it, or it goes too fast past the value. Doesn't everybody hate this? But yeah, surface pressure, it's been set to 1.91 atmospheres, but once again, sulfur hexafluoride means we can have 1 atmosphere of pressure. I mean, 1.91 is still pretty habitable for humans. I'm sure humans can survive. Yeah, humans can survive. I thought it was 2.5 atmospheres that was lethal for humans. 2.5, 3 atmospheres, assuming an Earth-like oxygen composition. But yeah, comment if you find out anything else. I'd love to know. But yeah, Europa, it's 143. Last time it was 128 at the same condition. It's once again the scale height thing. Scale height is how much atmospheric pressure drops. So yeah, so let's say scale height here, 13.4 kilometers. For some reason this doesn't have miles, but yeah. So But so up at 13.4 kilometers above the surface, the atmospheric pressure is 1 over E, Euler's number, of what it was on the surface. Now, it's not supposed to matter that much, but for some reason this thing takes it into its calculations. I don't understand why. But yeah, same thing again. 163. Come on. There we are. Perfect. So satisfying when you finally reach the perfect value without getting frustrated. Once again, 1.40 atmospheres as opposed to 1.93 in Io, but that's also due to the same old scale height glitch, quote unquote. So yeah, let's move on to Ganymede. Add some atmosphere, same 1 atmosphere. Once again, as you see, scale height comes in to play. So yeah. Come on. 163. 163. Let's do this again. 1 atmosphere. The infrared emissivity doesn't do anything, unlike how it does in the more recent versions. Once again, this one's at negative 149. You know what? Let's just take it as negative 148 because it averages out at the end. And seeing that both of these are negative 148 and so is this, you might as well call the average line here at negative 148. So let's set this to negative 163. So yeah, it'll just, no, 163, so it hits 15 degrees Celsius. Seems good. Now we have to add some water onto these planets. Yeah, what I love about the most recent version is that it doesn't do this. It doesn't fill the entire surface of the planet with water. Instead, does it gradually. But yeah, now we have some land as well. You see kind of faintly, but yeah. You can't change the planet color or anything. Not here. You can't even add city lights without modding. And modding is actually kind of hard. Europa is full of water. We don't need to worry about that. Now they say that Ganymede and Callisto are full of water, reflective of their densities. So yeah, let's mimic that. And for some reason, the density and scale height changes itself here. So now suddenly, surface pressure is 80 point. That's only, I don't know what this is doing right now. But yeah, let's set it to 1 atmosphere. That's 162. That's nearly perfect. Only needs a little bit more. 163. Come on. Come on. Yep, 163 it is. 1.02 atmospheres. I mean, that's definitely more habitable. Once again, I made a mention of the sulfur hexafluoride. So yeah, let's set this up to 163 as well. Yeah, looks like now we just wait. And here the planet actually, see how much scale heights? Okay, planet's actually warming up pretty quickly. It's unlike what was there in the more recent versions where it actually warms up pretty slowly. But I think the reason why it warms up pretty slowly in the more recent versions is because, yeah, planets do take time to warm up. They have a pretty large specific heat because they're huge objects. So yeah, let's check out Callisto. Yeah, it is also seeming fine. All these planets are ocean planets. But who said we can't put pontoons or whatever they're called? Floating rafts. What are pontoons anyways? I kind of forgot recently. But yeah, floating rafts on the surface so we can actually make it habitable. Come on, catch on. Here we are, Europa. 14.2, not bad. Why is it at 149? It was at 148 before this, negative 148. Let me increase this up a tad bit. Let's see, come on, get to 164. Yep, 164. It's gonna take a little bit to adjust. Now IO is moving too fast, I need to pause to catch on to it. Oh wow, it's a lot cooler than I expected. Why is it negative 149 again? Thought it was what? The occasional stuff like this happened in the previous versions, but at least it's not too bad. And the plants heat up quickly, which is an added bonus. Yeah, this video is turning out to be a lot quicker than I expected. Now, as I told you before, those simulations that they run, quote unquote, on the Terraforming wiki that they've already run and showed the results of, well, I don't know what they use to run. They don't use Universe Sandbox 2, I know that for a fact. So yeah. But once again, those are pretty neat simulations. You should check them out. Yeah, according to them, IO is, if it's negative, let's say it's 14.7, it's basically like that throughout the planet, day or night. Same thing can be said about Europa. Ganymede, it's basically the same, except there's like a 3 degree difference. 3 degrees Celsius, it's about 5 degrees Fahrenheit difference between day and night. At least that's what I saw in the simulation. Correct me if you find something else. Callisto, it's more like a 16 degree temperature difference. They're saying that in the equator, it's more like 16 degrees Fahrenheit. So in Celsius, that would be 10 degrees Celsius. So yeah, they say in the equator, 16 or 17, whatever. It's 72 degrees in the afternoon and 56 at night. While at the poles, it's 64 and low is 48. That's what they're saying there. It's actually a pretty neat simulation to check out. And why is Callisto cooling down? What's going on? This is not supposed to happen. I'm increasing this. I never saw these sorts of problems before. I've never seen these. Never on these versions. I don't know what's going on. And yeah, just the day I'm trying to take a video, there are problems that appear everywhere. Wow. Is this how much Universe Sandbox 2, or for that matter, even my computer hates me? I just can't believe it. Sadly for y'all, no heat map, because as I told you, 23.2 did not have heat map. That came out in version 24. Yeah, let's go check out the gravity of these planets. Now, these are not fully accurate. For some reason, this doesn't fully accurately model it, and it's kind of hard to fully accurately model it, but let's just use this model. 0.09 Earth. Let's see. This one is 0.12. So Callisto is about 9/100. Let's say it's closer to 1/10. Ganymede has 12% of Earth's gravity. Let's go check out Europa. Come on, Europa. Why is it cooling again? I'm really starting to get suspicious of this. I mean, I technically did click beta, but no. It's not supposed to be. It's not a beta version. So yeah, I don't know what's going on. Europa, for some reason, has higher gravity. Once again, this thing is confusingly modeled. So yeah, I think Ganymede's supposed to have more gravity. Let's go check it out. Yes, I have a lot of tabs open. Yeah, 1.428. That thing was modeling 1.17. I don't know. This thing's about, see, 1.428 over 9.8. It's 14.5%, 14.6%. Now let's go check out Callisto gravity. 1.236. That's also definitely higher. This thing was reading 0.9 or something. 0.236 over What's that? 9.8. It's about 12.6%. I'm using 9.8, could be 9.82, 9.81. I'm just going to use 9.8 for that matter. And yeah, let's go check out Europa gravity. For God's sake, stop showing Europe. 1.315. Really? 13.4%. It's more than Callisto, but I think that's also related to composition. Once again, Callisto may have a lot more water than we expect. Thing is, Europa's closer to Jupiter, so the tidal effects cause the water to be liquid, closer to the core. Let's go check out Io gravity. Why is it not showing this time? 1.796. That over 9.8 gives you 18.3%. Once again, Io is more silicates than the rest of these are more water. Why is this? Oh, I think I figured out what's going on. Jupiter has an orbital eccentricity of 0.05. It's affecting it. It's kind of frustrating to see that effect, but you know what? I'm mostly fine with it because they're going to remain habitable basically all year anyway. All Jupiter year anyway. Let's go check it out. Really? Oh yeah, I remember this glitch. The landing glitch. Well, I guess we can't check a planet out except from a distance. Yeah, for some reason you can't even change the atmosphere color, and sometimes the atmosphere renders as almost nothing. Even here you can only see a tiny bit of clouds. I don't know why it did that back then, but yeah. Now that sudden blink of black was not a glitch, but rather just Jupiter's shadow falling on Europa. It's basically a lunar eclipse if you were standing on Jupiter. Or a solar eclipse if you were standing on Europa. Let's go check out Ganymede. Hope it doesn't glitch out. Oh look, it didn't glitch out this time. Let's go check it out. Yeah. Jupiter's lit. It's in the crescent phase. I think it's waxing crescent. Let's see. Yep. Wow, that's beautiful. Once again, Ganymede's tidally locked to Jupiter. Now we're about to see a solar eclipse. Yep. Let's go check out the surface now. Yep, it's a tad bit darker, but sadly it's not simulated here on the surface. You need to go outside to see. But yeah, pretty cool. Well, come on, that missed by an inch. Let's go. Just want to go back out and see how it is. Come on. Really? Really? Wow, sometimes I just... Yeah, this game hates me. Why is it missing by an inch every time? An inch! Seriously? You know what? I'm just gonna keep on trying this. Aha! Got you this time. Really? 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 I mean, it is somewhat darker. Yeah, you saw that sudden darkness, didn't you? Can't slow-mo that, though. Let's go land on Io, see how it is. Yeah, sadly, this thing can't even simulate. Why is this glitching out? Told you, this is that glitch. Well, at least we're able to see it somewhat. Let's go check out Jupiter from here. If I can... Whoa! That is insane! That is insane beyond insane! Let's go check it out. Wait, what? What? That's really cool, but... I'm looking at a glitchy surfer that looks really cool. You know what? It's fine. Once again, these all are habitable right now. Let's go check out the rest of these. The enemy Callisto. Let's go check out Callisto. Let's go see how slow Jupiter's phases are there. Come on. Yes, we stopped it finally. Let's see how it turns out. You need to go a little further out to see this effect. I don't know why. Some odd flashlight effect, but it's pretty cool. Now we have a solar eclipse on Callisto. And let's go to Jupiter and see if we're able to see a lunar eclipse there. Now you're always guaranteed one because the way distance works, the sun is way further away and Jupiter's way larger, so yeah. It's not like the Earth and the Moon where the Moon is 400 times smaller than the sun, but it's also 400 times closer to the Earth than the sun. Let's go check it out. I don't know what's... Let me change the FOV. Let me see if that changes anything. Not changing it to 0, it literally crashes. See... 30... Let's go change it to 1. No, that's not happening. Let me change it to 10. Works just like it does in Minecraft. If you want to find out more, just go look at Fundy's video on infinite FOV. I don't know why this solar eclipse is not simulated. Let's change this to 5. 2.5. 1.25. Okay, so the sensitivity controls are not too bad. That looks pretty good. Let me change this to 0.6. It doubles it every time. Oh god, now the sensitivity is getting a little terrible. When I say terrible, I mean out of control. Zero 0.3, 0.15. Don't make it hit 0. I'm serious about this. Or you know what? Since y'all would love to see it hit 0, let's do that, shall we? Oh no, it doesn't let you do that. Oh wait, there is a minimum after all. Thank God. Change to 180. Yeah, that's pretty cool. Once again, yeah, it basically changes when you're, yeah. Looks like the sun's now a pulsar. Let's change it back to 45. So yeah, there we are. All of Jupiter's major moons terraformed, well outside the habitable zone. And yet they've been terraformed successfully. Not talking about plants. Plants can grow on Jupiter. Not on Jupiter, I mean Jupiter's moons if they're terraformed. They can grow as far as Neptune is what, once again, from Terraforming Wiki they say. It's about like, Jupiter received 1% of what's received on Earth. Which looks like it's enough to grow crops and stuff. Wait, is it 1%? No. It's 1 over 5.2 squared, which is somewhere around 4% actually. Yeah, 3.6%. Sunlight received by Jupiter. That's 3.7%. I think it's Saturn that gets about 1%. But yeah, plants can grow. So yeah, here we are. Once again, as I told you, sadly no city lights or recoloring of the planets / moons, but successfully terraformed. Finally, after so much time, I finally get to show you this. And that's the end of the episode today. See y'all next time.